Okay folk, welcome to AS Chemistry. What I'm going to do is record about 3 short videos that show you a few basic things that you need to know before you really start the course, or at least certainly have a good handle on within the first week or two of AS Chemistry. Otherwise you're going to find it quite difficult as the course goes on if you don't understand those basic ideas, or you don't have that basic level of knowledge to be able to access the course materials. Okay, so this is going to be the first one. This is going to be on chemical formula, and this is just how to write down the formula of compounds correctly. I'm just going to show you the formula of a lot of common compounds and ions that you should know what those formula mean, how to put them together into sort of a consistent formula of a compound. Just before we go whizzing into that, just to remind you that you have chemistry.weeklypart.org that you can visit. On here, and this will be useful for some of this, on the home page you've got the exam board data sheet, which is this thing here. So if you click into this link, one of the things you'll get is the standard periodic table that you get to use in exams, and that will be useful to you if you're practicing any of the calculations that I show you in one of the other videos. Okay, so we move away from that and we'll come to chemical formula. Okay, what I'm going to do is start with some common compounds and some common, what I'd call covalent compounds. From GCSE you should know the difference between a covalent compound and an ionic compound, but if you've forgotten, a covalent compound is where you've got atoms sharing electrons to form bonds where the electrons are roughly somewhere between the two atoms fixed in place, more or less, and they form what we call molecules. And molecules are discrete packets of atoms. So you've got a water molecule, which is H2O, and then you've got another water molecule over here. They're not chemically bonded together as such, although there is an interaction between them that makes them into a liquid at room temperature. So anyways, let's put some simple molecules. Alright, so let's start with H2O. Just to remind you, you should know what these formulas mean, but this 2 here indicates how many of the preceding atom that you've got there. So we've got 2 hydrogens, so that's water, fairly obviously. Okay, other ones that you should know: CH4, which is methane. Now you may know other hydrocarbons. This is made of carbon and hydrogen, so it's a hydrocarbon. This is a gas at room temperature. These go around as a packet of the 5 atoms, and then another methane molecule doesn't have a great deal to do with it, really. Okay, another really common covalent molecule in the course will be this one, NH3, which is ammonia, which is another gas. Where's my thingy gone? There we go. Okay, we could have higher hydrocarbon, C2H6, which is ethane, like that. Okay, and there's loads of covalent compounds. There's more covalent compounds than there are ionic compounds by a long shot. Okay, so there's a couple of simple covalent molecules. I'll come back to a few. I'm going to talk about ions now. Ions are things which have got an electrical charge, either positive or negative. So if you've got a positive electrical charge, you're talking about something called a cation. If you've got a negative electrical charge, you're talking about something called an anion. Okay, now cations tend to be made from metal atoms which have lost electrons, but cations aren't exclusively made from metals. You can have non-metal cations as well. I'll show you one example in a minute. You can judge the charge that a metal is going to have on it to some extent by the group that it belongs to in the periodic table. So if you look at group 1, in the periodic table, you've got elements like lithium. Lithium is in group 1, it's got 1 electron in its outer energy level, so it loses that to form an Li plus ion. Sodium likewise becomes Na plus, potassium K plus, and so on. Group 2. Okay, so we've got things like magnesium there, okay, and calcium here. These are in group 2, so they've got 2 electrons in their outer energy level. You might have noticed I've skirted around the issue of beryllium. Beryllium is starting to border on being a non-metal. It's sort of in between being a metal and a non-metal. And beryllium can form some ionic compounds, but can also form some covalent compounds. And this is where you'll find at A-level chemistry the division between things which are metals and non-metals, and the behaviour of elements becomes blurred in different circumstances depending on where they are in the periodic table. So if I went into group 3, okay, and the one that you're probably aware of in group 3 is aluminium, which forms a +3 ion. But again, aluminium can actually form covalent compounds as well as ionic ones. Okay. So if we look at, if you're looking at D block elements, things like zinc forms a 2+ ion. Copper is another common one you'll meet, is 2+. And there are lots of others. Iron, which is Fe, can form 2+, and iron can form 3+. Copper can also form 1+, by the way. And there are others, and we'll meet those, and we'll look at those in more detail in A2 chemistry, and why they form particular ions. So anions are the negative ones, and if you're looking at simple anions, so things like O2- is an oxide ion. Okay, and you notice that the end of a name of an anion changes to IDE, which indicates it's a negative ion. S2- rather than sulfur ion, it's a sulfide ion. Okay, and this extends to when you've got more complicated ions. Well, actually, let's have another one. N. Okay, so these sulfur and oxygen are both in group 6, so they need to gain 2 electrons to have a full outer shell. Nitrogen is in group 5, so it needs to gain 3. Nitrogen more typically forms covalent compounds, as does sulfur and oxygen, but you can get ionic compounds of them. This is a nitride ion. Okay, you get what are called rather more complex ions, literally called complex ions. We start joining a couple of atoms together. So OH- is a hydroxide ion. Hydrogen and oxygen, so it's a oxide ion with a hydrogen on it. That's a very common negative ion. Other ones include, let's have NO3-, that's a nitrate 5 ion. The Roman numerals in the brackets will become apparent later on in the course. It's just important to know that that's a nitrate 5 for the moment. Whereas let me just undo that. That's NO2- is nitrate 3. Do something called oxidation numbers. A couple of other common ones. SO4-2-, you've probably seen, that's a sulfate 6 ion. What else should we have? Let's have Cn-, that's a cyanide ion. If you like Coca-Cola, you like this one. That's a phosphate ion. That's a P, by the way. There doesn't look much like a P, but it's a P. Okay, that's a phosphate 5. Now the fact that these ones here all end in ATE means that they're an oxyanion. Okay, that means that an element, so sulfur or nitrogen, well actually not that one, that's a bad place to put a cyanidine. All of them except the cyanidine are oxyanions because they've got an oxygen joined to another element and it's negatively charged, so it's an oxygen based negative ion if you like. But you've got oxygen plus something else, generally several oxygens stuck onto some central, often non-metal element, and it's got a negative charge. So there are a few, there are more. Okay, a couple of non-metal cations, or whether it's non-metal depends on your point of view. But H plus is a hydrogen ion. NH4 plus is another example of a non-metal cation. Okay. A couple of the simple molecules it's worth mentioning while I'm thinking about it. O2, N2. I'm going to put X2 where X equals Cl or F or B. So I should have put F first, never mind. I2, halogens. Yeah, and the common thing is when people write nitrogen in chemical equations, they sort of get it wrong because they just put N. It's actually N2. A couple of others I'll put in there while we've got N is NO2, which is nitrogen dioxide, but you've also got other nitrogen oxides. You've got N2O, you've got NO as examples. A couple of other oxides I'll put in there, covalent oxides, SO2, sulfur dioxide, SO3, sulfur trioxide. You'll meet these in developing fuels and in the atmosphere unit as polluting gases. Another one you'll meet is O3, which is ozone, sometimes called trioxygen, but normally ozone. So one thing that we can do, and this is the last thing I'm going to do on the formula bit, is join these I'll make this, there we go. Join these together to make an ionic compound. And when you join cations and anions together to make an ionic compound, you need to have the same number of positives as you have negatives. Now sometimes this is fairly trivial, and I've missed the key one out here in the anion section. Let me just go over here. So things like Cl minus, Br minus, F minus, I minus. Okay, these are halide ions. So for example, that's a chloride ion. Okay, there are other halogen containing ions that you'll meet later on, things like chlorate ions and stuff like that, but we won't worry about them at the moment. So if we had K plus and Cl minus, that is KCl, potassium chloride, because we've got 1 plus and 1 minus. On the other hand, if we had Mg 2 plus and Cl minus, we would need to have 2 chloride ions, because each chloride ion has only got 1 minus, so we need 2 of them to counter the 2 positive of the magnesium. Works the other way. Let's look at a more complicated example. If we have an ammonium ion here and a sulfate ion here, and we're going to make ammonium sulfate, this has got a 2 minus charge, this has only got a 1 plus charge, so we need 2 of these. Now this is a more complicated beast. Because that's 1 unit, you've got to indicate you've got 2 of the whole unit. So you put brackets around it and then a 2 outside the brackets. SO4 2 minus. So that's ammonium sulfate. If we do it the other way round, and let's just pick one more, aluminium sulfate. Now we've got to have the same number of charges. We can't just simply double it up. What we're going to do is double the aluminium and triple the sulfate to get 6 plus and 6 minus. So that's Al2 brackets SO4 brackets 3, which gives us 6 negative charges and 6 positive charges. Okay, so that gives you a feel for some of the formula that it's kind of expected that you're going to know, and you're certainly going to pick up in the first couple of weeks. But if you just know what a sulfate ion is, and you know what a phosphate ion is, you know what a nitrate 5 ion is, and you just know there are group 2 elements going to form a +2 cation, that's really, really helpful from the word go. Okay, so that's the first little tutorial thing that we're going to do today.